Hey there, fellow coders. This is me, the Web3 Idiot. Congratulations on making it to the last episode in our intro to JavaScript arrays. Episode 1, if you missed out, was different methods that you call on a JavaScript array. Episodes 2 through 10, wow, impressive. Those are questions that we tackled using JavaScript methods. And you've made it to our last one. This is the hardest of the easy questions, I guess. The hardest of level 1 of JavaScript arrays. The idea here is to solve this question. We need to find the max sum of a subarray. So what exactly does that mean? Let's say we're given an array of 2, -4, 5, 2, -2, and let's say 9. So here, what exactly is a subarray? 2 is a subarray, -4 is a subarray, 5 is a subarray, 2, 4, and 5 is a subarray. 9 and 2 together would not be a subarray. It would have to be 9, -2, and 2 to be a subarray. 9 through 2 is also a subarray, even though it is also it is actually the array itself. So a subarray can be an array as well. So what we want to do is find the maximum total that we can get from a subarray. So basically what we would do, we'd look at this 2, okay, 2, okay, then we look at this -4 plus 2, that would be -2. So this 2 by itself, it's still higher than this 2 and this -4. Then we have this 5, 5 is higher than this -2 and this 2, so 5 would be our new max. 5, then we have this 2 here, 2 plus 5 is 7. 7 is higher than the 5 by itself. Then we have a -2, so we have a 5. So that would be, the highest point would still be, what would that be? That'd be a 5 here. And then 9 plus this 5 would be 14. So this is, oopsie, what are we doing? This is 14 together. This is 7. This is 5, this is 14. So 14 would be our output, because these numbers here added up would be the maximum subarray sum that we could get. There are 2 different approaches that we can take. I guess I'll keep 14 there. The first would be a simple loop plus loop, a double loop. So basically what this would do would be, we'd look at this 2, and then we'd have a current max variable that we keep outside. So we say, look at this 2, we say, wow, this 2 is 2. Then we look at it combined with this one, it is -2, we keep the 2. Then we look at it, the combined value of these, and then the combined value of these, the combined value of these, and the combined value of these. Then we move on, starting from position 1 in our array, do 1 plus 1 plus 2 plus 3 plus 4, and then plus 5. Then we move on to index 2, which would be 2 plus 3 plus 4 plus 5, and then we do all of these together. And eventually we will hit every single combination of numbers. And yeah, we would output the 14 that way. Our next way would be a thing called Kadane's algorithm. Wow, that's pretty cool. Basically, the idea would be that we have this 2 here. 2 is the max. Each position, you see what is the max total ending in that position, pretty much. What does that mean exactly? We'll go more into depth once we code it out. But for now, we'll just stick with this for now. Let's look at time complexity. Look at our first version. We have loop plus loop. Oh no, loop inside a loop. You know what that means? That is O of n squared. Wow, that is not good. O of n times n. All right, and then our space complexity, that would just be an O of 1, because we just have an external variable keeping track of our max. For number 2, we go through it just one time. So this would be an O of n operation, which is linear. in our best case scenario for this, and it would also be an O of 1. Actually, it would be O of n, because we are keeping track of all the values at each index. Well, you'll understand in a second. So let's go ahead and get into implementing this. So let's look at our first one. We have loop inside a loop, so we say function max sum subarray, and we'll call it loop. Inside we'll pass it an array. Then out here we'll say let our current max, and we'll call it we'll look at we'll call it the very first value. And then here we'll say for let I equal 0, I is less than array dot length, and we say I increments. Then here we'll call it this one, called let sum, this is our current sum, equal, all right, equal what? Let's see, we want to let it equal to, I guess 0, right? Yeah, we'll let it equal to 0. And then inside here, we'll have another loop. We'll say for let j equal I. J is less than array dot length. And then we'll say j increments as well. And then here we'll say sum plus equals, and we'll say array at j, which would be the 0. So our first sum would be 0. And then what we have to do is we need to see if our current max needs to be updated. So we say cur max equals, and here we can use math.max, which means we find the maximum value, where we compare current max to the sum we are adding up here. And then that goes through, and at the end we will return our cur max. So yeah, that's about it. So let's do this together. So we have a 2. We'll go 0, 0. So array at 0 would be 2. So our sum up here would be 2. Then we compare 2, 2, 2, and we keep 2. Then we do 2 plus -4, which would be -2 here. So this here would be -4. The current value of sum would be 2. Those together would be -2. Then we compare the current max, which is 2, to the current sum, which would be -2, and we keep current max. All right. Then we go on and on and on, and eventually we reach the end. So we can do a quick console log just to check it out, and we can say max sum subarray loop, and inside we will pass, let's just keep it simple, we'll pass in this. We are expecting 14. So if I put this here and I click run, over here we do in fact get 14. So that is pretty cool. Just to run you through it again, basically the idea would be that we have a current max. So we'll do cur. And actually let's do it with a smaller subset. So for this, we are expecting to get a 5. With this updated one over here, we get a 5. So let me run you through it with these 3 numbers. So first up, we have cur max will be started off as equal to 2. Then we go into our loop. Sum is equal to 0. So we'll call this one a loop. Loop where I is equal to 1. Then here we say sum is equal to 0, okay? Is equal to 0 at that point. And then here inside we have a loop where j is equal to, at this point, why is j? This would be 0. Where j is equal to 0 as well because it's equal to I. Then we say Sum plus equals j at array at j. So we say sum is now equal to 2 because array at 0 is 2. Then we compare this 2 to this 2, and guess what? They're the same number, so we just keep the 2 here. That's this line here. Then we go back up here to j is now 1, so we have -4. This becomes a 2 plus -4, so a -2. So this j moves ahead. We compare this -2 to the current max of 2. We keep this 2 here, and we increment ahead of j, 2. So this would now be 5 plus -2, which would be 3. And we say, we compare this new sum, 3, to the current max, which was 2, which would now be 3. Then we increment ahead of I. We reset sum to 0, and j is now equal to I, which would be 1. So we start off with sum is -4. Then we compare -4 to 3. We keep 3, and we move ahead. J is now 2. So we add 5 here, so this would be 1. Then we compare 1, this 1 here, to the 3. We keep the 3 because it's greater than 1. And then finally, we move ahead, and this I here to 2. Sum is now 0. J is now 2. And we add 5 to the sum, which is this 5 here. We compare this 5 to this 3, and we find out that this 5 is greater than the 3. And then we return the current max, which would be 5. Yeah, so that's how that one works. Next up, we will be looking at our Kadane's algorithms. Wow, this is a fun one. So basically what we're going to do is we're going to have 3, 4, and 5. I'll put these inside of comment. So basically we will have Kadane's equal this, and then we'll have our input is equal to, what do we say? We have a 2, -4, a 5, a 2, -2, and a 9. Sure. All right, so basically what we do is we look at this position and we say, this position looks pretty cool. And of course, we also have to keep track. Whoops. But I guess we don't really need to be this, but we'll talk about it in a second. Basically, what we want to do is we also want to have a global max. And basically, what we do is we look at this 2, and we say 2 compared to itself is just 2 would be our maximum here. So 2 is the greatest amount. Then we look at this -4. So then we say this -4 plus this 2 compared to just the -4. So we have a -2 and a 4, -4. So what happens there is the maximum value here would be -2. Then we have this 5. We compare this 5 to this -2 and itself. So 5 plus -2 is 3, or is it just 5? So 5 would be our next current max for this. Then what we do here is we look at this -2. We look at -2 plus 5, which would be 3, compared to a -2. The max here would be 3. And then we have this 9. We have 9 compared to 9 plus 3, which would be 12. And yeah, you just keep the 12 there. And pretty cool. So the output for this one would be 12, even though up here it says 14. What happened here? What did I get wrong? Oh, I didn't add this 2 in. Bah. Yeah. That's okay. Sorry, we forgot to add in this 2, which would be the 7 here. And then this would be 5. And then this would be 14. Sorry about that. I'm going to leave that in there. So, good luck. Yeah, so we have 2. And that's pretty much all that happens. And we also need to make sure that we keep track of our global max. So it would be 2 compared to -2, okay? Then it would be 5, and then it would be 7. 7 compared to 5, keep the 7, then it would be 14. And we would output our 14. All right, so let's go ahead and code this up. So we'll do function Kadane. And we'll put it an array, and remember what we want to do is that we will have let global max equal array at 0, because that will always be our initial first greatest value. And then we'll also have let Kadane equal an empty array, pretty much. There is another way to do it, but we're going to keep it simple this way. And it's just a simple for loop. So for let I equal, oops, 0. I is less than. Actually, just go ahead and start this off with array at 0. And we'll start here at 1. I is less than array.length. I increments every time. So we say, what are we going to do? So we're going to say Kadane.push. And what are we going to say? We're going to push the array at I. So we need to find the max, math.max, either array at I, or we will compare array at I plus Kadane at I minus 1. And then here we'll say if Kadane at I is greater than global max equals Kadane at I. And yeah. And then at the end, all we got to do is return global max. And you'll see console.log, and we'll say Kadane, and inside we will pass it an array, the same array that we had above, and we're expecting a 14. Let's go ahead and run it. And we do, in fact, get a 14. Very good. Yeah, so that's about it. I'm sorry if I confused you a bit with the implementation of this, but yeah, just trying to help you guys expand a little bit, and hope it made sense. If you have any questions, post them below. I'll get back to you. And thank you for finishing up the series on JavaScript Arrays. Bye.